Hello, Programming 12. So now we're going to be taking a look at why p-vectors are awesome and why we're doing all this stuff in the first place. So do you remember last year when we were making the clicker game and we did things like, we'd run and sometimes we'd get a lovely start to the game, but because we're just randomizing the X and Y, ooh, that's a fast one. Here we got, oh, that was a little slower. That's a calm one. And this one, we're doing fine. Sometimes you'd get like a really slow one, right? Not succeeding at getting that, but theoretically, you could definitely get a slow one. Random, man, it's so random. Like, what if they randomly chose, 0 and 0? Our target would be barely moving, and according to the mechanics of the game, that one's much slower, right? According to the mechanics of the game, that would give you an advantage. So we talked a bit about, how could we limit keep the speed constant, but choose a random direction. And we ended up having to use trigonometry, and that was just a side lesson. I don't think it was even on the videos. We just kind of talked about it. We could use trigonometry and angles and sine and cosine to kind of calculate a new x and y, and the hypotenuse was a certain value, so we locked the speed in but changed direction. Well, that was a lot of work, and I love trigonometry. I think that's great, and we could just do trigonometry, but guess what? Vectors do it all for us. They do the math for us, and that's kind of nice because that's why we invented computers in the first place, right? We wanted machines to do the annoying math that was too time consuming or too error prone or whatever the situation was. So inside of p-vectors are all that trigonometry, and we just need to use like basic functions to harness that without having to think about them. Think about like the ratios and all that. So here's an example. Here we got new p-vector. We're giving it some sort of a value, right? We're saying it's going to be these random x's and y's. Well, you know what? Instead, what we can do is we can just give it, whatever number we want. I could say maybe 5 and 0. Right? So that means it would be moving 5 to the left, right? Yes, right. It'd be moving 5 to the right. And if we just run that, I guess we can confirm that's true. Yeah, there it goes. It's just going to the right. So, its speed is 5. And we could choose a speed for. Our speed is kind of locked in with the direction. We can't really choose a speed. But you can manipulate that with vectors. So, for example, velocity allows, any p-vector, we'll use velocity, allows you to rotate it around sort of 0. So if that right now is, you can imagine as an arrow, that's 4 pixels pointing to the right. I'm not sure how this is turning out in the video. It might look like it's going to the left. I apologize. But you can then use the rotate to spin it around by a random amount. So I can say velocity dot rotate. And then I could choose a particular number. Like I could choose, I guess we're going to be using radians. So I could use pi, for example. That's at 180 degrees. If I run that, you'll see it'll go in the opposite direction. If I did pi divided by 4, that's 45 degrees. Ooh, yeah, I think so. Let's find out if I'm wrong. Yeah, 45. And you can see that it's actually spinning sort of the opposite direction of standard angles in math. Usually in math, like angles go around the unit circle, what's the word? Counterclockwise. Well, because of the upside down axis, y-axis, in processing and all computer graphics, they're going to go around this way. So they're going to go down through the fourth quadrant as they rotate around. So we can just rotate it. We can also rotate it by a random amount. So I can choose a random number between 0 and 2 times pi. That's 360 degrees in radians. So that's fantastic. We need one more parenthesis there. So now I just choose a random direction, but the speed is locked in at 4. And now whatever direction it goes in, it's always speed 4. I just have a random direction. So this is where p-vectors are so nice. They let us separate speed, which is like the magnitude of the arrow, and the direction, which is the angle that the arrow is pointing in. So the separation of those two things is really valuable. There's some other functions we can use too. For example, you can say, let's go over to game. So a thing you can do is you can change just the speed without changing the direction. I'll just put this in game clicks. I won't even worry about like if we're clicking. Actually, no, I'm not good enough. I'll just do, if we click the mouse, we'll speed it up. So how do we just talk about the length of the arrow, the magnitude? Right now we know it's length 4. So I can say something like this. If I click, I'm going to say velocity dot set mag. So set mag means set magnitude. That's the length of the arrow. So for example, right now I know it's 4. So I can do whatever the current value is and then just like multiply it by a certain amount. You can also get the current magnitude. So maybe I'll do that first. Let's just print out the current magnitude. So let's do velocity dot, I think it's just mag, which I would prefer if it was get mag, but okay, that's fine. They made a choice. We can live with it. So let's look at that. So when I click the mouse, it'll tell us the magnitude. And I'm pretty sure it should be 4. I forgot to print it out. Print line velocity dot mag. Okay, let's try again. Boop. Okay, so check it out. It did indeed turn out to be 4. So we know that it knows its velocity, the magnitude of its velocity anyways. Great. And I guess what we're going to do now is we're going to set the magnitude. So whatever its current magnitude is, we can do velocity dot set mag. So whatever it is, times 1.1 or something, or we could add 1 to it, whatever we want to do. We can make it 5, 6, 7, 8, 9. That would work out nicely. And maybe we'll do a little print line just to see what it is. Velocity dot mag, just to confirm it is changing. Oh, we'll see it on the screen. So notice that the direction doesn't change. The magnitude, like I'm clicking like a maniac here. Click, 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 click. I'm just increasing the velocity in a linear fashion. Just adding 1 to it. The direction isn't changing at all. That's something we couldn't really easily do. We would have to multiply the Vx and Vy by some number. So the velocity was geometrically changing, like exponentially. Changing. So now we can linearly change the velocity, or we could make this multiply. We could still do it the old way we did it. That's fine too. It'll like rapidly get out of control. And just like go crazy. But that's fine. There's nothing wrong with that. If that's the way you want to do it. But the point is that we can control the magnitude, which is sort of your speed, separately from your direction, which is the angle at which it's going. Last but not least, there's one other thing I'll just mention. It's also nice to know that you can find out the angle. You can print line velocity dot heading. So heading, think of like, in sci-fi movie, like, the spaceship is flying through and they're like, what is your heading, Captain? That kind of thing. Like, it's actually nautical terminology for like the direction you're going in as an angle. So the heading will tell us sort of what our angle is. Unfortunately, it tells us in radians, so you do what you got to do. So I'll just click, and we'll notice that like it can tell us sort of what our direction is. And we can use that information as well in the future. It'll be really nice to do that. Okay, so thanks everybody. I hope you enjoyed seeing some of the advantages of PVectors. And the video is getting kind of long, so I'll stop there. But there's more to know about exciting things about PVectors, so stay tuned. Okay, thanks everybody.